So here's the BDBI Aquatic project website, which includes a homepage hosted on Google Cloud Platform, and it includes various information like the title of the website as well as the description of it. And it also includes things like the website and project's overall goals and mission, which are to essentially identify water-related issues and to address them using analytics to prevent water disasters and to also address water access across the world. And we currently have two kinds of analysis so far, which include flood and drought vulnerability as well as the oil spill detection. And they use ML models to essentially predict and or identify different kinds of disasters across the world using satellite imagery and different kinds of map data sets we currently have access to. The oil spill, first of all, contains information about different worldwide oil spills and water bodies, which include, locations like the Gulf of Mexico or even like Puerto Rico or like states like, Washington and Massachusetts. And to begin with, you can press the individual icon to see what kind of severity it has for the location here. And it shows the individual like location as well as coordinates, the area it affects, as well as like the date it occurred, the time and severity of the incident, as well as metrics like the kind of amount of oils that spilled, as well as the area it covers when it spills onto the surface of the ocean. So all kinds of information are gathered here based on various data sets across national and international databases, as well as stuff about different metrics that affect how likely it is to spill oil into a certain region. So that's our oil spill feature so far, and it's mostly just American region for now. Going back to the other tab, though, we also have the flood data, which includes a more worldwide exploration of how floods and droughts might occur in the future based on past incidents of soil moisture data as well as past rainfall precipitation data. And we use this to sort of predict our time series model to generate what kind of output it has, which just means essentially the probability of having a certain flood or drought occur in a certain region in that given time frame of next month or week or whatever it might be. So we have, for example, in the next 5 days, we can predict the amount of the probability of there being a flood occurring in the area of Southeast Asia, aka, let's put in for now, Phnom Penh and Cambodia for now. Let's see if it shows the amount of, there's a model data that outputs, right? So it shows, for example, for Phnom Penh, it shows the outputted data around the center of the city as a radial outward graph of the kinds of probability density functions at each individual point. You can see the various kinds of probabilities on the given region using this icon you can click onto, and it shows the various risks as well as the longitude and latitude for the location given our previous data. And it predicts using like metrics such as the precipitation as well as soil moisture data that comes from past data sets, and it can predict accurately the next probability of there being a flood happening in the near future, in the next 5 days, for example, and that location given on our map based on user output that equates into the model and generates an output based on the past data as well as the user location that's given in the input and stored into a database in MongoDB. So it shows the individual locations within Phnom Penh, Cambodia here. And there's clearly a lot less risk in the east than there is in the center and the west part of Cambodia in Phnom Penh. So we can see which parts of the city are in general more prone to being flooded in the future and project those more readily as we go on to the future and try to mitigate where the most affected areas are in the future based on the metrics we measured in this model here. So we can see there's more floods happening in the center than there is happening at all in the northeast, and we can do that for various locations around the world as well as seeing what kinds of locations in the world are most prone to floods happening in general. So it's nice to have this model in hand just to use it to predict and analyze what trends in the world might cause floods to occur more readily based on data from satellites and data from NASA and things that you can use to predict worldwide flood occurrences. And here is our layout again. You can also log out here as well from the website to exit your termination or your session. And here we go. That's our website for now for BDBI Aquatic Sustainability. Thank you for watching.